So it is officially day 5 in Algebra 2, so I'm just going to label the top of my worksheet as day 5 so I don't forget. This is Algebra 2 and this is our day 5 worksheet. Okay, and it is Monday, March 31st, end of March. That came really quickly, I feel like. This year is just flying. Okay, so whenever we've been factoring quadratics or these trinomials, these expressions that have 3 terms, anytime that our first term, my goodness, let's focus first. Okay. Whenever our first term, our A, is 1, we know that our factors are going to be x plus or minus something times x plus or minus something. But now we've moved on to where we have trinomials where our first term is not 1. Now it's bigger than 1. So we need to just quickly review what we do whenever that is the case. So I've started making a little flow chart that might help us, and we might take some notes on this today, or maybe I can make you some copies. But I'm going to show you this. So here's our form. We always know it's going to be ax squared plus bx plus c. This is familiar. We know when our a is equal to 1, this is what our answer looks like. Our factors will look like this. But now, whenever our a is greater than 1, we're going to start by checking for a greatest common factor. So, looking at number 1 on this worksheet, let's identify our values for a, b, and c. So, what's our value for A? 3. What's our value for B? -2, good. And C? -5. So, can all 3 terms be divided by the same number? No, no. 3, -2, and -5 don't have a greatest common factor. So, I've gotten this far in my little chart I was making, the 2 yes options. But now, and don't worry about feeling like you got to write all this out. I'm going to make copies of this for you guys. No. What do we do when we can't do a GCF? We're going to have to include A in our answer. So I'm going to write no GCF. So whenever A needs to be included in our answer, we're really thinking about the factors of A. So my A is 3. What are the factors of 3? Just 1 and 3, or 3 and 1. So we really can only have this option here, where we have 3p, because our variable is p, and what would be the first term in my second set of parentheses? Just p, yeah, perfect. Okay, so we've gotten to this point. Our A is included in our factor pairs. Where do we go from here? The factors of -5 of C. So let's see. Whenever C is negative, what are the signs of our factors? 1 positive number and 1 negative number. So the factors of -5, we'll just start with -1 and +5. What else? Yeah, -5 and +1. We'll just flip-flop them. We'll just flip-flop the numbers, right? Because 5 is a prime number. The only factors of 5 are 5 and 1. So we have -1 and +5, or -5 and +1. So from this point, where do we go from here? We're going to do the rainbow method. Oh my goodness, what does that mean?
It means you're going to try all the options. Plug them in.
We're going to try plugging in these options of factors into our parentheses here. And we're going to do some rainbow method checking, and I'm going to show you that again. So let's just start with the first option. We have -1 and +5. So -1 plus 5, right? And the rainbow method is just where you're multiplying the inner terms and the outer terms. So let's do the inner terms. What's -1 times p? -1p. And 3p times +5, 15p. Okay, 15p. Now, what do we do next in this method? We're going to add them together. So 15 minus 1 is 14p. So, what does this 14p tell us? That this is not our answer. How will we know when we have an answer? Yes, our addition problem that we just did here needs to be the same as our middle term, which is -2p. Since this did not give us that same middle term, this is not our answer, so we need to try the next pair of factors. So let's try 3p minus 5. And p plus 1. Let's see what that does. So we'll use the rainbow method again. We're going to multiply our inner terms and our outer terms. So -5 times p, what does that give us? -5p, perfect. And 3p times +1? 3p. And what happens when I add -5 plus 3? You get -2p. What does -2p tell us? It's the right answer, because when we use the rainbow method, our middle term matches -2p. That means this is our answer. This is our factored form. All right. So I'm going to zoom out of that just a little bit and go back to this chart I was making. Let's see. So in this scenario, we said no, there was no greatest common factor. So we decided to include A, or 3, in our parentheses. So let's see, how could I write that? When there's no GCF, we include A in our factor pairs. And that would be like this. A x plus or minus something, and x plus or minus something. Okay, and then we use the rainbow method to check. Okay. Now, before I start moving this to the side, would any of you find this useful right now? Okay, how about this? How about I make a copy of this where it is at, and we can all have this so that we can continue kind of filling in the rest of it together. Would that be nice for you all? Okay, cool. So quick pause on what we're doing. And I'm going to run and make copies of this. As I am gone, let me know if you have questions about this. Use that time to think about if there's anything you didn't understand why I wrote. Please feel free to ask me about it. So I'm just going to pause this real quick. All right, we're back. And now we all have a copy of this, so we can all follow along. So we just completed a problem where our A was greater than 1. And we followed this process. We checked for a greatest common factor, and there was not one. So, since the answer was not yes, we went down to no greatest common factor, so we included A in our factor pairs. A good thing to note here is also that we know A is in our factor pairs, but what process did we end up having to do here? We included A, and then we used which method? The rainbow method, yes, where we multiply the inner terms and the outer terms. So if maybe you think, okay, I know it's going to get to here, but you think you might get stuck, here's another note we can make. I'm going to say, use the rainbow method. To check the factors of C that add up to the middle term. And I'll just draw a little chart of what that might look like. Let's see. Our AX, I don't know, plus, I'm just going to put a random number in these for our example. So that would be like 1x plus 2x. Okay. So this can serve as a little reminder for what to do when we get to a scenario like this. So let's actually look at number 2 on our worksheet as well, because this is a very similar problem. Number 2 is. So we'll go through the same process again, and I'll give us just a minute to write if that is what we are doing. Hi, Delon. Okay, so I am going to have us look at number 2 on our worksheet, but before I do that, I'll ask, is anybody still writing this? Do you guys want me to wait a second? Okay, I'll wait just a minute. I'll pause it. Go ahead and look at number 2 now. So, on our worksheet now we have problem number 2. Where our A is 2, our B is 3, and our C is -9. So looking at the flow chart, first let's check, is our A greater than 1? It It is greater than 1. It's 2. A is 2 in this problem. So, since A is greater than 1, the next step would be to check for a greatest common factor. Is there a greatest common factor? There is not a greatest common factor. So, because the answer is no, we're going right back to the same steps we just did. That means A will be part of our factor pairs. So what is that going to look like down here below? What will I write in my parentheses? 2n and n. And we're doing that because we need our first term to multiply to 2n squared. 2n times n is 2n squared, so that works. Okay, so now we have A included. Where do we go from here? We're going to look at all the factors of C, which is -9. So, what are some factors of -9? -1 and +9.
-3 and 3.
Perfect. -3 and +3.
-1.
Yes, then we could also have -9 and 1. Okay, so here's a few options. We've got our factors of C. Where do we go from here? Guess and check. Let's do that rainbow method and see if we can come up with an answer. So whenever we are doing this, what is it that our rainbow method answer needs to be equal to? 3n, our middle term. I need to have my answer add up to 3n. So which pair do we want to try first? Sure, let's try -3 and +3 and see what happens. So we'll multiply our inner terms and our outer terms, and let's see what that gives us. We have -3n and 2n times +3. What does that give us? 6n. Okay, and what is -3n plus 6n? 3n. What does 3n tell us? This is the right answer. This is the same as our middle term, 3n, and we got 3n. So this is our answer. We got lucky. We got it on the first try. Very nice. So we circle it. This is our answer. That's all there is to that. Hi, JT. Come on in. Here, let me pause this real quick. Okay. So now we have done 2 problems where A is greater than 1 and there's not a greatest common factor. Do we have any questions about what we've done in these 2 problems? No questions? Okay. Let's look at one where things get a little trickier. I'd like us to jump down to number 8. We've got some larger numbers here. And this one I think might take a little bit more space, so I'm actually going to rewrite this problem on a piece of notebook paper. So let's just do that. This is number 8 on that worksheet. 9k squared plus 66k plus 21. Okay. All right. So, number 8. How should we start this problem? What should we identify first? Our A, B, and C. A is 9, B is 66, and C is 21. So, let's take a peek at that little flow chart. A is greater than 1, so what do I do next? Say it again. We will have to include it if there's no greatest common factor. Should we check for something first? Let's check for our greatest common factor first. Let's make sure that we cannot reduce these numbers. So I have a 9, a 66, and a 21. And let's just pull these out to the side. I'm going to write 9, 66, 21. And let's see if we can divide these by anything. Can I divide all 3 terms by 2? No. What about 3? Yes. Yeah, we can do 3, so let's divide by 3. What's 9 divided by 3? 3. 66 divided by 3? 22. 21 divided by 3? 7. Okay. So we can divide by 3. Now we have 3, 22, and 7. Can I divide by anything else? I can't divide by 2 because they're not all even numbers. The next number I could try is 3, but 3 doesn't fit into my other terms. So that means we are done. We can only take a 3 out. So 3 is our greatest common factor. So looking at that flow chart again, yes, was our greatest factor equal to our A, which was 9, or is it smaller than A? It's smaller than A. So divide all 3 terms by the greatest common factor. We just did that. And write it outside of your parentheses. And this is where we're going to fill some more of this chart in. So let's start by doing that. Our greatest common factor was 3. So we're going to write a 3 here. And in parentheses, we're going to write our reduced quadratic. 9 turned into 3. So our first term would be 3k squared. 66 was reduced to 22. So now I have plus 22k. 21 was reduced to 7. So now I have plus 7. Okay. Is everybody following to this point? We see what's going on? So we've just divided our quadratic expression by 3. And now we have 3k squared plus 22k plus 7 left over. So now we're going to kind of go back to the beginning. We have A, B, and C again. New values though. So with our new quadratic, we know that there's no greatest common factor. We just went as far as we could there. So we're going to go back down to this step. Since there's not a greatest common factor within this set here, now our new A needs to be included, just like in the previous problems. So the only extra step we need to do is we are including A, but we also bring down that greatest common factor we took out. We just need to include it in the answer. So, when we have no greatest common factor, we include A in our factor pairs. Our new A is 3. So, in our parentheses here, we'll have 3K and K. Okay. Where would we go from here? Yes, now we just go back to what we always do. We're going to find the factors of C and do a little guessing and checking with our rainbow method. So, what are the factors of 7? 7 and 1, 1 and 7. That's our only options. Which one do we want to try first? Let's try 1 and 7. Plus 1 plus 7. All right. 1 times K is 1K. 3K times 7, 21K. What do these need to add up to? 22K, our middle term. 21K plus 1K is 22K. So, because the rainbow method had us adding up to the correct middle term, this is our answer. It's just like what we've been doing. The only extra step is that we had our greatest common factor that came out first, and it just gets included on the outside of our answer like this. Bless you. What did you get? You did too? Okay, tell me what kind of different answers we got. I'm going to look at yours, Cheyenne. Come and show me what you did. Let's see. This was number 8. Ah, okay, so this is not incorrect. This is a way to factor. But because you didn't take the greatest common factor out first, it wouldn't be considered factored completely. So can I use your work as an example? Okay, I want to see, did anybody do this?
That's exactly what I did.
I bet a bunch of you did.
I had 9K.
Ah, okay. So, something that we see and we learn and figure out in math is there are about 1 million ways to solve a problem, okay? Now, let's talk about this. I'm going to write here, I'll let you keep this, Cheyenne, and I'm going to write out your work a little bit. So, what you might have done is maybe you didn't take a greatest common factor out first. I'm going to rewrite the problem and show the thought process. 9K squared plus 66K plus 21. So some of you might have decided, well, A is greater than 1. I don't want to look for a greatest common factor. Let's just do 9K and K. You can do this, but it won't be factored completely. It will be factors, but it won't be as reduced as we can possibly get it. We're going to get bigger numbers in our parentheses versus we have a 3, and a 7. So let's see what would happen here. So I have my 9K and my K. What would I do next? Factors of C. Factors of 21 are 1 and 21. 3 and 7, 7 and 3, 21 and 1. Okay. So we could go through and try these. Let's see. Cody, which numbers did you end up getting here?
3 and 7.
3 and 7. Okay, so let's do that. So 3 and 7 plus 3 plus 7. All right. And whenever we use our rainbow method, we'll see that it does add up to 66. 3K and 7 times 9 is 63K. When you add them, you do get 66K. So this is correct, but let me show you something. K plus 7 is fully reduced. This matches the second half of my answer. But 9K plus 3, 9 and 3 have a greatest common factor, don't they? 9K plus 3 can be factored further. What can I divide both 9 and 3 by? 3. So, if I divide both of these by 3, I end up with 9 divided by 3 is 3K plus 3 divided by 3 is 1. And since we divided by 3, we included on the outside. And you see now how we got from here to here. It's the same answer, it just wasn't fully factored. So that's where we might run into trouble, is forgetting to check for our greatest common factor first. Whenever we do it first, we won't have to do any more reducing at the end. Does that make sense? That clarify it a little bit? Okay, so we'll keep doing some more practice and just get that in your brain. We want to check for the greatest common factor first. That way, whenever we get when we use the rainbow method and we get that our middle term, it does match, we can say, okay, I know I'm done. I don't need to reduce any further because I already took all of the divisible numbers out. Okay, now Cheyenne, you did it with a 3 and a 3, right?
Yeah.
Okay, let's see.
And I used 1 and 21.
Okay, so 3K plus 1 and 3K plus 21?
Yes.
Okay. Here's another one where we could reduce it further. 3 and 21 are both divisible by 3. So this would need to be reduced further. And this is what would happen. 3 divided by 3 would give us that K, the 1K, plus 21 divided by 3 is 7. And that 3 goes outside. So again, you'll end up with the same factors, the 3K plus 1 and K plus 7, then with the whole number 3 on the outside.
So with mine, you would put it like the 3 in between the parentheses right there?
So with yours, I always say to put the whole number on the outside, and then these can be technically in either order. Okay. So what I would do on yours, Cheyenne, is keep your 3K plus 1. Let me just kind of rewrite your whole answer. I'd bring the 3 out to the side, and then your 3K plus 1, and then our K plus 7. And that would be your answer. And that's exactly what we got up here. Oops. See that? Does that make sense? Okay, cool. Yes?
We do 16.
Number 16, yes. Let me flip to that one. Okay, let's flip to number 16. Oh, this is a fun one, negative numbers. All right, I'm going to teach you a trick on 16. Now, I'm going to tell you on your quiz, I'm not going to give you one like this where they're all negatives, but it's good to know that it exists. Number 16. I'm going to rewrite this one as well. Let's see. Okay. So here's number 16. This one is all negative terms. Negative 6a squared minus 25a minus 25. When you have a leading term that is negative, my first suggestion will always, always, always be to turn it positive. We're going to factor out -1 first. Just to make everything positive, it'll make it a lot easier. So here's what that would look like. You could either go through and divide everything by -1, or we could just rewrite it, but with a minus on the outside, and we'll change the sign of everything else. So negative 6a squared becomes positive 6a squared. Minus 25a becomes plus 25a. Minus 25 becomes plus 25. So in this case, the first factor that we divided every term by was -1. Or we could think of it as factoring out the negative. We don't necessarily have to think of it as 1. We're taking the negative sign out and putting it outside here. Is anybody confused by what just happened here? Okay, so think of it like this. We're doing the opposite of, for example, let me get a sticky note. This will be a little side note.
So if I can be like really honest right now.
Yeah.
I feel like my brain is trying to grasp it, but it's not quite there yet, so this is not going to make any sense to me because I'm still struggling with the rest of it.
I getcha. So let me ask you this. Whenever we're factoring and a is equal to 1, where we have like the x and the x, and we just find the factors of c, you feel good about that?
The A, B, and C part, I got that part. It's just that when we have numbers on, we're bringing them to the inside and then on the outside, it's confusing.
I gotcha. So let's start thinking about kind of the basic operations of multiplication and division and how we write those. So for example, if I had, let's see, how can I explain this best? I understand where it's getting confusing because I'm thinking even as I teach it, it makes sense what's coming out to me because I know why I'm putting it there. Let me, I want to make it clear to you. So, like if I had a problem like this, a minus 24x plus 3, for example. If I told you to distribute the negative, would you know what I meant by that? Yes, you're basically taking everything times -1. So this positive 24x would become what? Negative 24x. And my plus 3 would become what? Minus 3, yes, or -3. Perfect. So anytime that we have a minus sign or a number outside of parentheses, it means that we're multiplying it by each item inside, that distribution here, right? I'm taking that negative sign onto both of these terms. And then it becomes negative 24x minus 3. What's happening over here, where we're putting things in parentheses and writing numbers outside, we're doing that because we're basically doing the exact opposite of this. Since we started with positives and we multiplied what was outside to get negative, if we start with negative, we need to put it on the outside to get the positive. It's like we're going in reverse. Just like, let me give you another example. 2 on the outside of, let's say, 4x minus 5. is it reasonable to say that this is the same as that? Yes, these are the same. How did we get from 2 times 4x minus 5 to 8x minus 10? How did we get there? We multiplied. Yeah, we distributed. 2 times 4x is 8x. 2 times negative 5 is negative 10. So if we were to start with 8x minus 10 and say, what if I go backwards? What if I divide by 2 for both of these? This is where the number on the outside comes from. If I divide by 2, they get reduced. 8 divided by 2 is 4. 10 divided by 2 is 5. And we're going to stick that 2 out here to show that we didn't lose it. We still have everything here. 2 times 4x minus 5 is still equal to what we started with. It's just telling us that 2 times this, like this is the factored form of 8x minus 10. We're working in reverse here. And I'm hoping that helps a little. I might have to make some more little practice things to get us feeling good about putting the numbers outside. I think we're going to get better at it. We're going to do so much more practice today. Yes.
I think a good way to explain it too is kind of like what Cheyenne and I did with the larger equation.
Yeah.
Trying to get the simplest form possible.
Yes.
So if you need to add in that step of breaking it down with the 9, different, and then you can break it down
Right.
to like another level.
Yeah, and that's a great way to think of it. We're just trying to reduce it to the smallest numbers that we can have as possible, because that's going to make factoring easier. So let's go back to number 16 and kind of continue working through this and see what we can do with it. So I'm going to move that just over to the side. So we just divided each of our terms by -1 essentially. So now we have that negative on the outside and our terms became positive. So we have our A, B, and C. Is our A equal to 1? No. So what do we need to do?
Include it.
We could include it, but what should we check for always? Always check to see if there's a greatest common factor. We want to see if we can reduce at all. Is there a greatest common factor? Can I divide them all by 2? No. Can I divide them all by 3? No. By 4? By 5? By 6? No. Once I've reached my smallest number, 6, I know I can't have a greatest common factor. So, because there is no greatest common factor, now we do include it in our factor pairs. So, we go to the next step. We're going to keep our minus, and we are going to start factoring. So, we could try 6A and A. Is there any other idea or option that we could try if 6A and A don't work?
3 and 2.
3 and 2. Because remember, these terms, the first 2 terms of each set of parentheses, need to multiply to 6A squared. So 6A times A makes 6A squared. But the other option would be 6 is equal to 2 times 3. So we could try 2A and 3A. So these are 2 different options. All right. And where do we go from here?
Factor out C.
We're going to factor C. Let's see all the factors of C of 25. So what are our options?
1 and 25, and 5 and 5.
1 and 25, 5 and 5. That's it. I guess you could also do 25 and 1. Oops. So those are our only options. And what do I need to do with these?
Put 25 and 1 in.
Sure, let's do that. Do we want to try the 6A and A first, or the 2A and 3A?
2A and 3.
Okay, let's go down to 2A and 3A. Let's try that. And you said 25 and 1?
Yeah.
Okay, so let's use some reasoning here. If I do 25 and 1, first of all, what am I trying to get using the rainbow method? What should my numbers add up to? B, our middle term, which is 25A, right? If I know that I need it to add up to 25A, if I include 25 as one of my factors here, is that ever going to add up to 25? It won't. It's going to be way too big. It's going to be way too big. So I'm going to say that it's probably not going to be either of those. Want to try 5 and 5? Let's try it. So plus 5, plus 5. Okay. So where do we go from here? Let's do the rainbow method. We've got 5 times 3A, 15A. And then 2A times 5 is 10A. 15A plus 10A is 25A. It works. So this would be our answer. This would be our answer. Okay. That's our factors. How do we check our answer? How do I know that I did it right?
Do the rainbow method.
You could do the rainbow method. Is there any other way that we could check it? There is a longer way. The rainbow method is kind of the quick way of doing it. But let's say you just really want to make sure that you're doing it totally correctly. What could I do with these? You could, yes, distribute, multiply them. We could use our FOIL method or our box method to check, going back to one of the first days of class. So let's just look at that real quick. We'll make sure that it multiplies to our original problem. So let's write 2A plus 5 and 3A plus 5. All right, which method do we want to try? FOIL or box? Let's do FOIL. Okay. So, using the FOIL method, what would I do first? My first terms, that's 2A times 3A. What's 2A times 3A?
6A.
6A. Then my outer, so it's FOIL. So we did our first terms. Now let's do the outer terms. 5 times 2A, that'd be 10A. My inner terms, 5 times 3A. We actually just did the outer and inner up here. 15A. And my last terms, 5 times 5, 25. And we still have that negative. So we would just combine like terms at this point. 10A plus 15A, and that's 25a oh, I forgot my squared. Sorry, guys. Now we have our negative. And then if we really wanted to, we could distribute that negative, which would give us negative 6a squared minus 25a minus 25. And is this the same problem that we started with? It is. It is. So that means we did it right. That means we did it right. Factoring is just finding what two things can I multiply together to get to this thing I'm telling you. The negative 6a minus 25a minus 25. We just found the two binomials that multiply to the trinomial. And we checked our answer. Okay? So, that's what we just did. Let's run through a couple more of these.
I have a question.
Yes.
Everyone confused me.
Yeah, absolutely.
Okay. Can you still do that, or is that not simplified enough?
You technically could do that,
Okay.
but I would recommend taking that negative out and making them positive. If you didn't, though, it wouldn't be wrong.
Okay, cool. Appreciate it.
Absolutely. Okay. All right. Okay, guys. It is just about time for the end of period 1. And I think we could use a little break, honestly. Let's go ahead and take our break. And we'll come back at like 10:35-ish. That'll give you about 15 minutes. During our break, if there's anything in particular that you're struggling with, come talk to me. I really want you guys to feel good about what we're doing in here, and I want to help you however I can. So come back in about 15 minutes or so, and we'll talk about this some more. All right, so we're back from our break, and what I have decided, if you didn't hear me just a minute ago, is I think it is going to be a great time to just look at this practice quiz and hopefully get our confidence up a little bit, because you'll notice on worksheets sometimes there are problems that are a lot trickier than what I will actually quiz you over. So we're going to go through this practice quiz together. I encourage you to follow along and write all of these answers down, write your work down. This is the best time to ask questions. If I write something, don't copy it on your paper if you don't know why we're writing it. Raise your hand, interrupt me. This is the best time to make sure you're getting it. As we go through this, also keep in mind you will be able to use this on your quiz when you take the quiz. So your quiz is going to look almost identical. Same kind of questions, just slightly different numbers. So on the very first page, we have 4 problems, 4 quadratic expressions, and all 4 of them have leading terms of 1. A is 1. So this will be a little bit of a review, and we'll start with the first problem here. For number 1, I have x squared minus 9x plus 8. What's the value of a? A is 1, our b is negative 9, and our c positive 8. Since a is 1, what do our factor pairs look like? X and x. That's it. So we're going to start there. We know this is what our pairs will look like. What should I do next? Yeah, let's list out the factors of C, of 8. And remember, when we have a positive C, there are two options for what our factors, their signs can be. So we need them to add up to b, our middle term. b is -9. Will two positive numbers ever give you a negative answer? No. So what do we know about the signs of our factors? They need to be negative. So we could do -1 times what to make 8? -1 times -8. Perfect. We could do -2 and -4. Good. And we'll leave it at that. So let's go down the line and see. What is -1 plus -8? -9. And on the first try, we have our numbers. So, since -1 plus -8 equal -9, what do we do with these numbers?
Plug it in.
Plug them in. -1 minus 8. And that's our answer. We're done. So we'll circle it. Notice at the top I wrote, show your work and circle your answers. Please, please do that. I know sometimes, let's say you don't get the right answer, but you show a lot of really good work. I can give you half credit or partial credit for doing certain steps right, even if you get the wrong answer. So showing your work is always a great idea. I guess unless, of course, you're somebody that can just do this in your head and you feel really confident about it, that's great. But if you make a mistake and there's no work for me to look at, the whole problem is just wrong. Show your work. It'll only help you. Any questions about number 1? Okay, well, let's look at number 2. Now we have x squared minus 7x minus 18. Our A is 1. What are B and C? Perfect. -7 and -18. So because A is 1, what should our factor pairs look like? The x and the x, yes. And then we do have a -18 for C. So we're going to look at the factors. And Cheyenne, you were jumping ahead. Tell me, what do we know about the factors in -18?
They're both going to be negative.
So two negatives, if I multiply two negatives, they give us a positive, like over here.
One positive, one negative.
Yes, we're going to do one positive, one negative. Perfect. Okay, so yeah, let's try, what'd you say, +3, -6? Sure, +3, -6. What are other factors of -18? Yeah, we could do 2 and -9. What else? Or do we want to stop there? One and -18, absolutely. So let's start thinking about these. How am I going to know which pair of numbers to use? They need to add up to our middle term, -7. So I'll just write that over here just to remind me. And let's start adding these together. What is 3 plus -6? -3, so it's not that one. 2 and -9. -7. So, since 2 and -9 add up to -7, our middle term, those are the numbers we're going to put in our parentheses. So what's my answer? Perfect.
And then x minus 9.
X plus 2, x minus 9. That's our answer, so we circle it. Very nice. All right. Any questions on number 2? Okay, let's go ahead to number 3 then. And again, please stop me if you do have questions, or if I move too fast, if you still need to see part of my work, you can tell me to move back. I'm happy to do that. So for number 3, we have another expression where a is 1. We have x squared plus 3x plus 2. So because a is 1, just like the last two, what do our factor pairs, our binomials, look like? X and x. Good. And where do we go from here? Factors. Factors of c, of 2. There's really only one option here. 1 and 2. I guess you could also do 2 and 1, but that won't change our answer here. What do these need to add up to? 3. Our b is 3. Either one works. 1 plus 2 is 3. 2 plus 1 is also 3. So you really have 2 options for the correct answer here. How do I write my answer?
X plus 1.
Good.
X plus 2.
X plus 1 and x plus 2. You could also do x plus 2 and x plus 1. Both are correct. So we circle it, and that's our answer. There's the factors for 3. Okay, any questions on that one? All right. So now we'll look at number 4. Here's the last one on the first page. And again, our A, B, and C. Because A is 1, our factor pairs are just like the last 3. We have x and x. What's my next step? Yes, let's list the factors of C. We have a negative 10 for C. Say it one more time. Yes, our factors need to add up to our middle term, B, which is 3. So since we have a negative 10, our factors will have different signs, right? We need one positive and one negative. So let's start listing them out. We could do negative 1 and positive 10. What else?
Negative 2, positive 5.
Good. Negative 2 and positive 5. We could do that. Let's see if either of these work. What's negative 1 plus 10?
Positive 9.
Positive 9. That's not the answer. How about negative 2 plus 5?
3.
3. That's the answer. So, where do I write them in? Good. X minus 2, x plus 5. That's our answer. So we circle it. Okay, that is the whole first page of your quiz. It will be just like this. You'll have 4 problems where A equals 1. You'll factor them just like this. Any questions on the first page before we go to the second? Okay. All right. So let's go to the second page. And now we have quadratic expressions where A is greater than 1. So let's start with number 5. When you have a leading term that is bigger than 1, what do we always need to check for first? Greatest common factor. Don't forget, let's write that really big up here. I'm going to say all 4 of these are going to be the same. Check for GCF first. C, can I divide all 3 numbers by a number? Don't forget that step. Okay, so number 5. I have 5, 15, and 10. Are all three terms divisible by something? What are they divisible by? 5. So, let's divide by 5. And since we're dividing by 5, we're going in reverse and turning this into what looks like a distribution problem. Where does the 5 go? On the outside. So because we divided by 5, that goes out here. And now we need to write our new reduced terms in the parentheses that we're creating. So our first term, 5x squared divided by 5, what does that become? X squared plus 15x divided by 5. 3x, good. Plus 10 divided by 5. 2. Awesome. Okay. So, is anyone confused or not sure how we got from the first step to the second? We just divided by 5. This was the new terms after being divided, and we kept that 5 on the outside here so that we don't lose it. Okay. So now we have new numbers for A, B, and C. What's our new A? 1. So it's not the X, it's the number in front of it. And since there is no number, we assume there's an invisible 1. So A is 1, B is 3, C is 2. Now since A is 1, it's a little bit easier, right? What do the factor pairs look like for a quadratic where A is 1? In parentheses, those two binomials. We want it to multiply to x squared. So remember on the last few problems, when A was 1, we would have x and x to get x squared. Now we have x squared again. So we're going to do the same thing, right?
X plus 1 equals 2.
Yeah, so we're going to have an x, you're right, Dylan, and an x. The only difference is we need to bring the 5 down, right? Bring that down. And now we just are factoring like normal. Just pretend the 5 doesn't exist. Factors of C of 2. 1 and 2. What do they need to add up to? 3. Our new B. 1 plus 2 does equal 3. So, that's what goes in the parentheses. Plus 1, plus 2. And that would be our answer. With the 5 on the outside, yes. To show that whenever I do x plus 1 times x plus 2, I'm getting this answer, x squared plus 3x plus 2. If I take it times 5 again, I get back to my original problem. That makes sense to everybody? Okay. Any questions on number 5? Okay, let's look at number 6 then. And all of these on this page are going to be this exact same process. We'll take a greatest common factor out, and hint, hint, we'll be able to do it like normal where it's x and x. Okay, on all of these. So number 6, 7x squared plus 35x plus 42. What do I need to check for first? Greatest common factor. Can I divide by something with all 3? 7. Let's do that. I'm going to divide everything by 7. So whenever I divide everything by a number, that number, just like in the previous problem, goes outside the parentheses. And then we write the reduced quadratic inside. So, 7x squared divided by 7, what does that become? X squared. 35x divided by 7. 5x plus 42 divided by 7. 6. Good. And now we have an a that equals 1. So there's A, B, and C. So now that we've gotten rid of our greatest common factor of 7, we've written it outside, we have a reduced quadratic expression where our first term is 1. What should we do next?
Find the common factors of C.
Find the factors of C, absolutely. And because our A is 1, we know that we'll be able to do this process here where we just add the factors together and find our answer. Because to get x squared, we just need x and x. But what am I missing?
7.
My 7. I got to bring that down. So my factors of C of 6, what are my options? 1 and 6, 2 and 3. Perfect. So 1 plus 6, what does that give us? 7. And that is not equal to our B, our 5. 2 plus 3, that is 5. That works. Okay, so what do I do with the 2 and the 3? Perfect. We're going to put them over here in our parentheses, x plus 2 and x plus 3. Not forgetting the 7. So that is our answer. That's our answer. All right, any questions on number 6? Are we ready for number 7? Okay. Again, stop me if you need to see anything still. I'm happy to go back. Okay, so number 7. 14x squared minus 42x plus 28. What should I do first?
Divide it by 14.
Let's see if we can divide by 14. Can we? We can. Okay, let's do it. So if I divide everything by 14, how does the next step look? What am I doing next?
14 before the parentheses.
Perfect. And what do all my terms become? I've got 14x squared. If I divide that by 14, what's left? X squared, good. Minus 42x divided by 14. What does that give me? 3x plus 28 divided by 14. 2. All right. And how nice is that? Our A is down to 1 again. So, our A is 1, our B is -3, and our C is +2. So what do we do next? We're going to have, well, let's think about it. We have a positive 2, so we need to think about what numbers can I multiply together to get a positive number. If I do a negative times a positive, I will get a negative number. I need it to be a positive number, so they have to have the same sign, right? If I do -1 and +1, let me write this out real quick. If I have a positive number, I have two options. I can either do a positive times a positive, so like 1 times 2 makes 2, or I can do a negative times a negative. If I do a positive times a negative, if I have different signs, I will get a negative answer as my product. But to get a positive answer, a positive product, you need two numbers with the same signs, because those negatives will cancel out.
But are we trying to get a positive, a -3?
We're trying to add up to -3, but we're trying to multiply to +2. So the goal is to find what two numbers multiply to C and add to B. So, because we have a negative B, we know that we're going to use the negative factors, right? Okay, so let's see, 1 plus 2 gives us 3, positive 3, but that's not what we want, right? Our B is -3. So we'll try that. -1 plus -2 gives us what we need, -3. All right? So, what's our answer?
14, parentheses, x minus 1,
Perfect.
and x minus 2.
Yes. 14, and then in parentheses, x minus 1 times x minus 2.
Is it still correct if you got x minus 2 and x minus 1?
Yes, it is. If you switch the order, that's a great question. X minus 2 and x minus 1, this is correct. It does not matter what order it's in if you have the same leading term here. That is still perfectly fine. That's a great question. So either one of these is our answer. Any questions about number 7? Any questions? Okay. Let's go ahead and look at number 8 then. So this will be the last one on page 2. I've got 3x squared plus 3x minus 36. What do I check for first? Greatest common factor. Is there a greatest common factor? 3. Let's divide by 3. Perfect. So that 3 goes outside. That becomes x squared plus x minus, you said 12. Okay. So now I have A is 1, B is 1, C is -12. What should I do next?
List the factors.
Yes, let's list all the factors of C. We have a negative number for C. What are the signs of the two factors that multiply to a negative number? One positive, one negative. Always, always. So, let's see. We need them to add up to +1. because that's our middle term, 1x. So let's think, we could have negative 1 and positive 12, negative 2 and positive 6, negative 3 and positive 4. We could also flip-flop these, negative 4, positive 3, negative 6, positive 2, negative 12, positive 1. But let's see what we've got here so far. If I need these numbers to add up to a positive 1, will any of these work? Negative 3 and 4. Negative 3 plus 4 equals 1. So that's what we'll use. What will our answer look like?
3, and then in parentheses, x minus 3, and x plus 1.
Perfect. 3, and then in parentheses, x minus 3, x plus 4. Perfect. And we'll circle it so that we know this is the answer. All right. You're more than halfway done with what your quiz will look like. And this is the second page. Do we have any questions about the last 4 problems we just did? Are we ready to move on? Everybody good? Okay. Let's flip to the third page. And here's where they get a little bit trickier. Now we have a is greater than 1, and the greatest common factor is not going to be equal to a, like in the last 4. In 5 through 8, we had whatever our value of a is, we were able to divide everything and get it down to just x squared as the beginning term. On these, we won't be able to do that. So let's see what happens in these scenarios. So I'm going to write that again at the top. Check for greatest common factor. That's always the best thing to start with. There might not be one, but that is the best place to start. So, looking at number 9, is there any greatest common factor here? No. I can't divide all of these by 7, and 7 is not divisible by any smaller number. So, this is where we can kind of refer back to that little flow chart. A is greater than 1. Can they all be divided? No. So what do we need to do? We're going to include it. This is where we don't start writing numbers outside of parentheses. We only do that when we can divide it out or it's a greatest common factor. Now, because we cannot reduce this, a gets included in our factor pairs. So, instead of x and x, what will we have?
7x.
Good. 7x and what? And x. Perfect. So we have 7x and x. My a is 7. My b is negative 31. And my c is negative 20. So now that I have my empty parentheses here, what should I do next? Let's list out the factors of c, just like we've been doing. I've got negative 20. Now, because we don't have a that is 1, we won't be able to just simply add the numbers together and see if they add up to our middle term. What method will we have to use in this scenario?
Rainbow.
The rainbow method. So, again, if you like writing notes and reminders, this would be a great place to say, we're going to use the rainbow method on this page. So I'm just going to write that. Rainbow method. So we multiply inner and outer terms. And add them together. Okay, so I'm going to start listing out some of the factors here of -20. We need what signs on our factors? One of each, one positive and one negative, yes. So we could have -10 and 2. We could have
-1 and 20.
-1 and 20. Sure, -5 and 4. We could also have, like, I don't know, -4 and 5. There's a lot of different options here. I could list out about 1,000,000 different possibilities. And here's where sometimes these problems take a little bit longer, because we're going to be doing a little bit of guess and check and thinking about whenever we do that rainbow method, they need to add up to our middle term, -31x. So, which pair would we like to try first? Sure, let's try -5 and 4. So I'll put -5 plus 4, and let's just see what happens. So that's going to give me, bless you, -5x, and 7x times 4, what's that give me? 28x. Okay. Let's see, -5x plus 28x, what does that give me?
23.
Yeah, positive 23x. And that's not equal to our middle term, is it? No, so that's not our answer. So we can cross that one off, and we can try another. Let's rewrite 7x and x. What should we try next? Plus 5 minus 4? So if we do that, since we've already used 5 and 4, we will get a different answer, but it'll be the same number. It'll just be -23 instead of +23. So we could do that, but I think we know it won't give us the right answer. Are you wanting to, you said do +5 and -4?
I put 7x minus 4 and then
Ooh.
x plus 5.
Okay, so let's try that. So -4 and plus 5. Okay, let's see. That'll give us -4x, and 7x times 5 is what? 35x. So -4x plus 35x is 31x. Now, this is very close. What do we need it to be instead of positive 31x? Negative 31x. So if you get the right number, but the wrong signs, what can you do?
Can't you like, let's say,
Yeah, you can just switch the signs. Keep the numbers exactly where they are, just change the signs. So let's try 7x plus 4 and x minus 5. Let's try that. Now this is, bless you, this is one where you may want to use an extra sheet of paper. That will be available. And we'll be able to see that it's going to work. 4x minus 35x. And what does that give us? Negative 31x, which is exactly what we needed. So this is our answer. 7x plus 4 times x minus 5. All right. There we go. Any questions on this problem? Any questions at all? Are we doing okay? I feel stress. I feel like we're stressed. Are we a little stressed? Okay, we're going to keep working through this. It will be okay. I'm going to do what I can to help you guys, okay? But please tell me when you're confused. I want to help. But I can't help if I don't know what we're not getting, okay? I really want to help y'all. You want to try number 10? Okay, let's look at number 10. Now I have 28x squared plus 16x minus 80. What should we do first? There's no greatest common factor? Well, I always say let's start with the smallest number we can think of that's not 1. So let's try 2. Can I divide all these by 2?
Yes.
I can. So technically there is some factor in there. I'm going to do this on a separate sheet of paper. Let's find the greatest common factor together. Let's see. I'll use a sticky note actually. So I'm going to write out my numbers. I've got 28, 16, and negative 80. Okay. So we can divide everything by 2, right? What's 28 divided by 2? Almost. 14. What's 16 divided by 2? 8. Negative 80 divided by 2? Negative 40. Okay. Can I divide by 2 again? Yes, I can. So let's keep going. I'm going to divide by 2 again. 14 divided by 2? 7. 8 divided by 2? 4. Negative 40 divided by 2? Negative 20. Okay. Can I divide by 2 again? No, I can't. I can't divide by 3. I can't divide by 4. I can't divide by 5. Well, 4 was the smallest number, so we stopped there. So, we can't go any further. You guys remember what I told you about greatest common factor? What do we do with these numbers out here? Not add. Multiply. Multiply. Because we divided by 2 and divided by 2, we're going to do the opposite. We're multiplying, right? So 2 times 2 is 4. That goes outside. And these 7, 4, and negative 20, that will be the coefficient on your new terms, right? So 7x squared plus 4x minus 20. And 4 would be your greatest common factor here. So let me move that to the side and I'm going to rewrite it on my paper. So we were able to divide everything by 4. And that goes on the outside. So now we have 7x squared plus 4x minus 20. And once we've taken out a greatest common factor, I like to just pretend that it does not exist until the end when I'm writing my problem. Don't let that 4 confuse you. It's gone. Now we're looking at this new quadratic that we've come up with. The only thing is just not to forget to write it outside your answer, just like we did previously. So we are here now. What's our new A, B, and C?
7x squared,
That's our A, it's 7.
b,
B is 4. What's our C? Negative 20. And we actually just found all the factors of negative 20 in the previous problem. So we can list them again, but if you wanted to save room, we could just look over at this chart we made. I'm going to write it again just because, I don't know, I just want to. Now, because A is greater than 1, and we cannot reduce it, what do we know about A and our factor pair answer? What am I going to do with 7? So we put a number outside when we divide it, but since we can't divide it, we're going to include it, right? Right? So like in this problem, we couldn't reduce it, so we included it. 7x squared, we kept the 7x and x, right? It's the same thing here. We can't reduce this, so it needs to be included in our answer. Okay? So instead of x and x, what will I have?
4 on the outside,
Yep, we have a 4 on the outside and then
7x,
7x. Good. If we can't get rid of it, you include it. If you can get rid of it by dividing, that's when the number goes on the outside. Whenever you cannot get rid of it, it stays in your answer. So we have 7x and x. And we'll need to decide which of the factor pairs will add up to b whenever we plug them in here. So, let's see. I'll rewrite them. We've got negative 1 and 20, negative 2 and 10, negative 4 and 5, negative 5 and 4, negative 10 and 2, negative 20 and 1. There's a lot of options here. What are we thinking?
Minus 10 plus 2.
Minus 10 plus 2? Let's try it. Okay. Minus 10 plus 2. Let's see what happens. That's the pair we're using. So how do we check to see if this is correct? Rainbow method. Okay, so I've got negative 10x and positive 14x. What happens when I add those?
4.
I get 4x. What does this 4x tell me? That it's right, because My new middle term is 4x. Because they add up to 4x, this is correct. That is our answer. Okay. Any questions on number 10? Okay. Can we go to number 11? Alright, stop me if you still need the work. I'm going to scooch my paper. Let's look at 11. 3x squared minus 5x plus 2. What do we need to do first, always? Check for a greatest common factor. Can I divide all three terms by anything? I can't. So, because I can't get rid of my 3, where does it go? We're going to include it in our answer. We're going to have 3x and x. Our A is 3, our B is negative 5, and our C is positive 2. Now this one's nice because we have a little c. Okay. So we know that it's going to be 3x and x. What do I do from there? Yes, let's find the factors of c, which is positive 2. Yes, our b is negative 5. So we need to make sure that we choose 2 negative numbers, because 2 positive numbers will never add up to a negative number. 2 negative numbers will add up to a negative number, and they multiply to a positive, so it works for both. So our only options are negative 1 times negative 2 and negative 2 times negative 1. Okay. So which one do we want to try? Let's try negative 2, negative 1. Okay. And how do we check if it's right? Rainbow method. So, negative 2x, negative 3x, what do they add up to? Negative 5x. That's B. That's our middle term. So, that's our answer. That is our answer. Any questions on number 11? Okay. Number 12 is the last one on page 3. So let's go ahead and look at it. Number 12, is there a greatest common factor? Nope. So, what does that mean? A needs to be part of our answer. So what do those pairs look like? 2x and x. Okay. We have our pairs. Now let's look at the factors of C. 21. Got 1 and 21, 3 and 7, 7 and 3, 21 and 1. 3 and 7? All right, let's try that. Plus 3, plus 7. Okay. And how do we know if this is right? Let's do the rainbow. So 3x and 2x times 7 is 14x. 3x plus 14x? 17x. There you go. And it matches our middle term. So this is the answer. Okay. That was the last problem on page 3. Do we have any questions at all? Okay. All right. Can we go to the last page? Or does anyone still need this? Stop me if you do. Okay. There's just 2 more like that. 2 more. So let's look at 13. What am I checking for first?
Greatest common factor.
Yes. Is there a greatest common factor?
Yes.
There is? What is it?
3.
3. Okay, so let's see. We can divide by 3, right? Let's see. What happens when I divide everything by 3?
Turn it to 3 before the parentheses.
Mm-hmm.
7x minus 45. Minus 28.
Minus 28. Okay. All right. So we can't go any further because we can't divide by 7. So A is 7. B is negative 45x, or negative 45. C is negative 28. What should I do now? Let's find the factors of C of negative 28. Hmm.
1 and 28.
1 and 28.
2 and 14.
2 and 14.
4 and 7.
4 and 7. Now, what do I know about the signs of these factors? One of them needs to be negative. Which pair should I try first? And we'll make one negative when we put it in. 4 and 7, is that what I heard? Okay. Do we want to try it with a negative 4 or a negative 7? We can try both. Negative 7? Okay, sure. Let's try that. I'll just make my second ones negative here. So, before I put those in, what do my factor pairs look like? So we got 3 on the outside still.
7x.
Good. 7x.
4.
And then, oh yeah, we're going to do the plus 4. So let's try that. Okay, so we got 7x and x. We're going to try the plus 4 and the minus 7 first. And let's see. Let's see what happens. What do they need to add to again? Yes, negative 45. So let's see. We've got positive 4. And 7 times negative 7 going to give me negative 40, good, 49. And what happens when I add those together? You get negative 45. Look at that.
Switch from the 7 to the 4, negative 4.
Yeah, we have 7x plus 4.
Same thing.
Say it one more time.
What if we switch it from a negative 4 to a positive 7, will it still turn out the same thing?
So read me your whole answer. Is it like the 3 on the outside and then 7x
Plus 4
plus 4?
with a negative 4.
Okay, so 7x minus 4.
What if we switch it?
Okay, here's what would happen.
It would be the same number, but this
Yes, so if you had 7x minus 4 and then x plus 7, here's what would happen when we do the rainbow method. We know that it needs to add up to negative 45x because that's our middle term. But whenever we check it, this is what will happen. We've got negative 4 times x, which is negative 4x, and then 7x times positive 7, which is positive 49x. When we add them together, we do get 45x, but we need negative 45x, yes. So we would just switch the signs, keep the numbers, yep. Perfect. Okay, so this would be our answer, and we circle it. That's it. Okay, any questions on 13? Any other questions? Okay. Let's look at our last one. (4x squared plus 34x plus 42). Can I divide by anything?
2.
2. Let's do it. Divide by 2. And where does that 2 go now?
Now it's on
Outside of parentheses. And what goes inside now?
2x.
Good. 2x squared plus 7. What is it? 17x. You're right. Plus. What is it? 21. Sorry, I'm not very good at hearing. I think I'm hard of hearing. Okay, so we have reduced. We have reduced. Can I go any further? I don't think I can divide again because I have a 2 and those are not even numbers. So we can't divide anything else, which leaves us with an A of 2, a B of 17, and a C of 21. So let's think about what our pairs are going to look like. We know 2 is going to stay. What are our pairs going to be?
2x,
2x
x.
and x. Okay. Now, what do I do?
Factor C.
Let's look at the factors of C of positive 21. So, keeping in mind that when we do our rainbow method, we're going to want our answer to be equal to 17 or 17x. So, let's think about this. What are some factors of 21? We've got 1 and 21, 3 and 7. I guess we also have 7 and 3, and 21 and 1, but we can move on to those if we need to. Are there any that we want to try first? 3 and 7, let's see. So, plus 3 plus 7, 3x, and 7 times 2 is 14. 3x plus 14x is 17x. So what does this tell us? This is our answer. We don't need to go any further. There it is. Very nice. Okay. Any questions on that one? Okay. I would like to show you guys one last thing. This is optional. If your brain is fried and you want to go, you can go. If you would like to learn one more thing, I am going to show you, I'm going to give you bonus questions that are very similar to this. And this is looking into what we'll start looking at next unit, which is coming soon. We're going to learn how to solve a quadratic equation. Now, it sounds scary, but it's not. It's really not. And it will only, again, it'll get easier as we do more and more. So we're going to start by factoring these like normal. So on this first problem, I have 2x squared plus 7x plus 3 equals 0. We're going to solve by factoring. So what would I do first? We're going to ignore the equals 0 for now.
Put a line down the.
Yeah, find, first, yes, greatest common factor. Is there one? No, there's not. So what does this mean about my factors? My factor pairs. My A here, my 2, is going to have to be included in my answer. Okay, so let's do that. 2x and x. And it's the exact same process. Let's find the factors of C, of 3. And there's really just two options, 1 and 3, or 3 and 1. One and 3? Yeah, that's right. So let's use 1 and 3. And we could check it with our rainbow if we like. That's going to give us 1x. 2x times 3 is 6x. And sure enough, they add up to our middle term, 7x. So we have our factor pairs. This is our answer for the factors. Now here's how to solve the equation. Since we know these are the two items that multiply to our original expression is equal to 0, we're just going to set our factors equal to 0. We're going to solve two problems. Since you all are most likely used to solving equations for one value of x, this will feel uncomfortable. When we have x squared in an equation, this means we're going to get two answers for x. So here's how we do it. I'm going to take these factors, 2x plus 1, and I'm going to set it equal to whatever number they give us. In this case, it's 0. And then I'm going to do it with the other one. X plus 3 equals 0. And now we just solve the equation like normal, which you all know how to do. So 2x plus 1 equals 0. How would I solve this? Just remind me. Minus 1 from both sides. And that would leave us with 2x equals negative 1. And then we just divide by 2, which would give us an answer of x equals, either negative 1/2, you could leave it a fraction if you want, or we could say negative 0.5. That's our first value of x. And the second one, we just subtract 3 from both sides and we get x equals negative 3. This would be your answer. So remember, these are optional. This is a bonus question. If you decide you don't want to do it, you don't have to. However, I would recommend trying it because even if you get it wrong, it won't hurt your grade. It'll only help it. Even if you get partial parts of it correct, you can earn like half bonus points. It never hurts. Never hurts. Okay, I'm going to show you the second bonus question. Last one. Is there a greatest common factor? No. So what happens with 3? It comes down. We'll have 3x and x. We'll do this one a little quick. I know it's almost lunchtime. We're going to look at the factors of c, factors of 8. 1 and 8, 2 and 4, 4 and 2, 8 and 1. Which one do we want to try? 2 and 4. Let's do it. Plus 2 plus 4. Okay. 2 times x is 2x. 3 times 4 is 12x. And sure enough, 12x plus 2x is 14x. So these are our factor pairs. This is correct. We've factored it. Now to get the answer to the equation, somebody tell me what would I do next? I just told you in the last one. What would I do? Yes, we're just going to set each problem equal to 0 and solve. So I have 3x plus 2 equals 0, and I have x plus 4 equals 0. Okay, and how would I solve the first one? Good, minus 2 on both sides. And that leaves... Good. 3x equals negative 2. Divide by 3. Good. So then we get x equals either, you could leave it as a fraction, negative 2/3, or you could say negative 0. What is it, 6 repeating? Okay, 0.6 repeating. Or you could round 0.67. That's okay with me too. And x plus 4 equals 0. We'll just subtract 4. And we get, yes, x equals negative 4. All right. That's the practice quiz, you guys. I will have the quiz available for you to take tomorrow if you feel ready for it. If not, feel free to come talk to me. I'm happy to work with you guys one-on-one. I would like tomorrow to be the official day that we take the quiz. But again, if you don't feel ready, you have the whole week to take it and to make corrections, okay? So feel free to use that quiz time to study more, write some notes, talk to me. I want to help. Let me know how I can. But that is all today. You're going to hold on to them. You'll turn them in with your quiz when you do take it. If anybody wants a blank copy of this practice quiz so they can kind of test themselves at home, you're welcome to take blank copies too. They're up at the front of the room. Pause that.